So as we close out the chapter, 12.4 and 12.5 involve measures of position and the normal distribution. So again, these two things play an integral part in working with statistics. Okay. So feel free to pause the video and read through this information. Uh, and again, I'm going to continue on, but feel free to pause it at any time just to kind of look at things. So when it comes to this measures of position and normal distribution, we're going to start to see these shapes appear. Uh, so when it comes to measures of position, that we also talk about what we call relative standing of an individual within that data set. So again, an individual could be about anything, but a lot of time, when I'm talking about, measures of position, a lot of times I think of it as how does my health compare to other people my age? What's my relative standing, with my general health? A lot of times parents will do that with their kids, at a certain age, how does my child's health compare to other kids their age? You know, and a lot of times you hear this in terms of percentiles. What percentile do we fall in? So a lot of times we do that in testing as well. So for example, if a student is in the 80th percentile on a test, they scored better than 80% of all test takers. So we see this percentile a lot with standardized testing, ACT scores, SAT scores, health metrics, like we're saying, children's growth charts, percentiles are used quite a bit. We also have what's called quartiles. Notice how quartiles involves dividing things into four equal parts. So we're not going to really deal with quartiles at this time, so we'll leave that alone. But we are going to look at z-scores. So z-score is going to tell how many standard deviations a value is from the mean. So we have this formula here that we can use, but instead of using uh, mu and sigma, these are for more like for population. Most of our examples are going to be involving a sample. So the formula we're going to be using is more of this one down here. So to find the z-score, we can use a formula to determine the actual z-score as long as we know the data item, the mean, and the standard deviation. This creates what we call a standard score. And from that z-score, we can determine how you fall with respect to percentages. So a z-score can be positive, which is going to be above the mean. A negative z-score is going to be below the mean. And if z equals zero, that means we equal the mean. So z-scores is going to be one of the measures of position that we're going to deal with. So I'll pause there for a second.